Now let's proceed to question number 9. Here in question number 9, a small block of mass m is placed on a wedge of equal mass m as shown in figure. Initially, system is at rest and friction is absent everywhere. If the block is projected with velocity v0 is equal to 2 root gr, then we need to evaluate which one of these 4 different options are correct. Okay, I would say initially the velocity was v0 and it will try to rise here. Let's say it rises up to height h from this label. So the first 2 questions were maximum height reached by the block, so I'll try to find this value of h. By the time it will reach the maximum height, both of these two, that means this wedge and the block, will be moving together with common velocity. Let's say it is v. So in that case, by principle of conservation of linear momentum, I would say mv0 must be equal to 2mv, or v must be equal to v0 by 2. So now, by the principle of conservation of mechanical energy, initial mechanical energy at this level, it was 1 by 2 mv0 square. Here it would be mg into h plus 1 by 2 2m, and this v square, it would be v0 square divided by 4. Have this calculation here. We'll be getting 1 by 2 m v0 square. This is 1 minus 1 by 2. It will 1 by 2 altogether. It is mgh, or m will cancel out. v0 square was how much? It is 4 gr divided by 4 equal to gh, and we are getting this value of h to be equal to r. So looking onto the options A and B, it is option A is the correct answer. Now let's proceed for the calculation of option C and D. Maximum speed of wedge is v0 and minimum speed of block is 0. Fine. Once it will reach here, they will attain a common velocity of v0 by 2, and again it comes back, and by the time it will cross from this position, we can take this interaction completely as the elastic collision itself, where initially this block was having the kinetic energy and it transferred those of the kinetic energy and momentum to the wedge, and finally it came back and now it is separating. So definitely we shall say that the velocity, momentum and energy will completely be transferred to the other wedge here. So initially the wedge was having the 0 velocity, so finally the block shall have the 0 velocity. So maximum speed of wedge is v0, that is the correct answer, and minimum speed of the block is 0. That means by the time the block will be coming down to this situation, it will have the 0 velocity and the wedge will have the velocity of v0. So for question number 9, we are getting option A, C and D as the correct answer. Now let's proceed to question number 10. In question number 10, a small air bubble of radius r is at depth d, that is much more greater than small r, from water surface. Atmospheric pressure is P0 and density of water is rho. Then pressure inside the bubble, and the bubble rises, its radius will increase or decrease. Well, one very common observation, or you may say as the concept itself, is if the bubble rises in the water, its radius will be increasing. So straight away I would say option D is the correct answer. Now of A and B, let's have the calculation here. If this being the depth here is the small bubble with radius r, so the pressure here was P0, so at this point we shall have the pressure P as P0 plus how much it is, rho g into d. Fine. So now if we take the bubble here, pressure P is just outside the pressure here, and inside if it is P dash. So what we know, the pressure P dash minus P must be equal to 2T divided by R. This is the pressure difference from inside and outside the region. What is this pressure is for? This pressure is the pressure just outside the bubble. So inside pressure would have been taken as P0 plus rho GD plus how much, 2T by R. So this is the final pressure inside the bubble at depth D. So which one of these two options? It seems or it is actually option B is the correct answer. So for question number 10 we are getting option B and D as the correct answer. Now we shall proceed to question number 11. Here in question number 11, 2 moles of an ideal monatomic gas undergoes through a cyclic process ABCA as shown. During the process AB, PT is constant. I mean, the description for this process has actually been given here. If temperature at A is 600 Kelvin, then work done on the gas in process AB and molar heat capacity for the process AB, heat given to the gas in process BC, and heat rejected by the gas in process AB. For most of the calculation here is concerned with process A to B, so let's mark those of the temperature, pressure and volume initially. It's been given the temperature here was T0 to be equal to 600 Kelvin, fine, and along this direction pressure and temperature multiplications, it is coming out to be constant, so pressure actually increased by 2 factors, so temperature must be decreasing by 2 factors. That means here how much? It is 300 Kelvin, and here the pressure would be 2P0 itself. Now from A to B we found that actually the pressure is increasing and the temperature is decreasing, so we need to evaluate first what is the specific heat capacity for the process A to B. If we try to show this process in PV diagram, we'll find it like this way. This is A, this is B, this is C. So here the temperature being how much? 600 Kelvin, here it is 300 Kelvin, and this is the process AB. So clearly from A to B actually the volume is decreasing, and so work is actually done on the gas. So if we try to evaluate all the calculation for this way, that means B to A, so all the results that will be coming here in this question would be just opposite to the process of BA. Let's have this calculation here. First we'll try to evaluate the specific capacity for the process, and it will be C is equal to how much? N minus gamma here, R divided by N minus 1 and gamma minus 1. For which process? For process PV to the power N is equal to constant, or here it is PV to the power N is equal to constant. That means for this part P square V is constant, or actually PV to the power 1 by 2 is equal to constant. Put the value of N to be equal to 1 by 2 and gamma to be equal to, it is monatomic gas, so it will be 5 by 3. We'll be getting this value of C to be equal to 7 divided by 2R. Okay, so work done on the gas in process AB. I'll calculate for process BA. It will be delta Q is N CDT, N is 2, C being how much? 7 by 2R, DT is 300, so it is 2100 R. This is the heat supplied in process B to A. And what is the change in internal energy? Delta U would be is 2. This is CV is 3 by 2 R into 300. It is coming out to be 900 R. So work done in process B to A, it is B to A. It will be 2100 R minus 900 R. It will be 1200 R. So from A to B the work will be done on the gas, and how much? The same value. So work done on the gas in process A to B is 1200 R, is actually the correct answer. And molar heat capacity for process A to B is 7 R by 2. This is also the correct answer. Heat given to the gas in process BC. BC is isobaric condition. So how much is the heat given? Delta Q in process BC is N 2. Specific heat capacity is 5 by 2 R, and change in temperature from here to here it is 300, so it is coming out to be 1500 R. This is the heat given to the gas in process BC, so option C is also the correct answer. Heat rejected by the gas in process AB from here to here, if it would have been going from B to A, we found that heat given was 2100 R. So in opposite process it must reject the 2100 R joule of heat. So the option D is actually the wrong option. So what we are getting here for question number 11, option A, B and C are the correct answers. Now let's proceed to question number 12. In question number 12, in a photoelectric effect setup, the frequency of incident beam is greater than threshold frequency and it is constant. Actually, frequency that is higher than threshold frequency and that is not changing at all. If intensity of incident beam is increased, then kinetic energy of most energetic photoelectrons increases. The most energetic photoelectrons will have the kinetic energy that will only be depending upon the highest of the frequency of the incident beam, and that actually is constant, so it shall not have any effect here. Stopping potential will increase. Yet again I would say the same reasoning, and it will not change. Stopping potential will remain unchanged. That's the answer we just mentioned here. And photo current will definitely increase because the intensity is increasing. It simply means the incident photons, the number of incident photons are increasing. So we are getting option C and D as the correct answer for question number 12. Now we shall proceed to question number 13. In question number 13, in a YDAC arrangement shown in the figure, a thin transparent sheet is introduced in front of one of the slits as shown. Then assume that the sheet does not absorb any energy. It is completely non-absorbing sheet here. So if we would consider this central point, the ray coming from here and here, so definitely this part would have certain extra path length. So to counterbalance that, we would be saying if we'll be taking some point here around, so that this length will exactly counterbalancing the extra length that actually was introduced because of this sheet here, then this point will be the 0th order maxima or the principal maxima. So central bright fringe gets shifted upward. That's the one we actually have stated here. So this is the correct answer. Now fringe width will remain unchanged. Yes, there would be some shifting and the fringe length would still be lambda d divided by small d itself. So it will remain unchanged. Intensity of bright fringe decreases. We have just mentioned that the sheet is not the absorbing one. So the amplitude that will be transmitting and the fringes that will be forming here shall not have any change over their relative intensities. So I would not say the option D would be the correct one. So what we got here for the question number 13, A and C are the correct answers. Now we shall proceed to question number 14. Here in question number 14, the equation of a standing wave formed in a 10 cm long string fixed at both ends is y is equal to A sin kx sin omega t, where A is given as 5 mm, k to be equal to 1.57 per centimeter and omega to be 314 per second. Then wave speed, simply how much it is? To be equal to omega by k. Very standard answer. Omega was 314, k being 1.57. How much this value would be? It is coming around 200 centimeter per second or 2 meter per second. So option A is actually the correct answer. What about the option B here? Velocity of particle at x is equal to 1 centimeter is 157 centimeter per second. At how much time? At t is equal to 2 seconds. Just differentiate this equation dy dt with respect to t and we'll be getting A, this part will remain as it is, kx, and it is cos of omega t, and here we shall have the value of omega. So what is the velocity here? A to be equal to 5 into 10 to the power minus 3, omega being how much? 314 sin kx. What about this value of kx? K to be equal to 1.57. It is actually pi by 2. Pi by 2 into 1. So kx is coming out to be pi by 2. So its value will be 1. That means the value of this part is 1. Cos omega t this time. So cos omega t, cos omega being how much? It is 3.14 into 100, I would say. It is 100 pi, and t being 2 seconds. So it is 200 pi. So the value of this part will also come out to be 1. So dy dt, that is the velocity of the particle, it is coming out to be 314 into 5 into 10 to the power minus 3 in meter per second or 1.57 meter per second, or we may say it is 157 centimeter per second. So option B is also the correct answer. String vibrates in fourth harmonic and string vibrates in fourth overtone. Let's have the picture of this standing wave here. What is the phase shifting altogether? It is 10 centimeters the length, and K being how much? 1.57. So if I'll put this value of 10 here, we shall have Kx to be, K was pi by 2 into 10 centimeters, so actually 5 pi. This is the altogether total shift. So pi, 2 pi, 3, 4 and 5 pi. This will be the structure of the standing wave altogether. From here to here the shifting will be how much? Pi, 1 pi, 2, 3, 4 and 5. So look which one is the correct answer. It is actually oscillating in fifth harmonics or fourth overtone. So string vibrates in fourth overtone is the correct answer. So we got here in question number 14 as option A, B and D as the correct answer. Now we shall proceed to question number 15. In question number 15, assume a smooth tunnel is made along a diameter of the earth, radius capital R, and a small particle is released from rest at small r is equal to capital R by 2 from center of the tunnel. Then we need to evaluate which one of the given options are correct. Let's take it as this being the earth, this is the central part, particle was released from this distance, that is R by 2, and this one is the capital R. What we know, the acceleration of the particle will always be towards the center, and its value happens to be how much it is? G capital M R cube R. This is the value. So it is towards the center and proportional to the displacement. So definitely it will be the equation of SHM. And in fact this is very standard answer, that we know the time period happens to be T is equal to 2 pi root under R by G. In fact, if the particle will be released from anywhere inside the region, from here, whatever the conditions, it will be executing the SHM with this much of the time period. Only there will be some variation in the amplitude. But here in the question, the amplitude was given to be A is equal to R by 2. How much is the value of omega? Definitely it is G by R. So particle executes the SHM is the correct answer. Time to reach the center of the earth, from here to here, it will take 1/4 of the time period. That means T dash will be pi by 2 root under R by G. So option B is actually the wrong option. What about the option C and D? Speed when it reaches the center of the earth, here let the speed is V0, it will be A into omega R by 2 into G by R, or it is square root of GR divided by 2. So option C is the correct answer, and the total mechanical energy of the particle is conserved, that is for the standard condition of simple harmonic motion, and it is moving in effect in the gravitational system itself. So that is obviously the very correct answer. So the question number 15, we are getting option A, C and D as the correct answer. Now let's proceed to question number 16. In question number 16, a cubical block of side A is on the ground. A particle is projected from ground with minimum velocity V0 so that it crosses over the cube. Then it's been just projected with minimum velocity so that it is able to cross this region. So this distance is actually A. So let the velocity here is V. So definitely this must be satisfying, so that this range will be maximum for this given velocity V. That means this angle theta here to be how much? 45 degree. For the projectile motion, we shall say the velocity component x direction shall remain conserved. So definitely here, if the velocity is V0, angle being theta, so I would say V0 cos theta must be equal to V cos 45, or V0 cos theta is equal to V by root 2. Other part is the mechanical energy from here to here will remain conserved, or I would say V square must be equal to V naught square minus 2G into A. This is our second equation. And the third equation, that is for this range. Okay, this range is how much? A. That is the maximum range, and for the range we know it is U square sine 2 theta by G, here theta being 45 degree, so I would say it is V square divided by G must be equal to A. So how much is the value of V square? V square is coming out to be G into A. This is our third equation. Just try to solve these questions for the theta using this equation V square is equal to GA and V square is equal to V naught square minus 2GA. I would say this is GA and this is 2GA, that is 3GA is actually coming out to be V naught square, or squaring this part now, it is V naught square cos square theta must be equal to 1 by 2 into V square, that is how much? G into A. How much the value it is? Cos square theta is equal to GA divided by 2, and V naught square is 3GA, or it is 1 by 6. Okay, so cos theta is how much? 1 by square root of 6. 1 by root 6. Let's see. We found V naught square to be equal to 3GA, so option A is the correct answer. And theta we found it to be cos inverse 1 by root 6, so that is the wrong option. Range, how much is the range actually? This will be the range. So the range will be, it is V naught square 2 sine theta cos theta by G. This is the value of the range. We found the value of cos theta here. We need to find the value of sine theta also. If this being theta, this is 1, this is root 6, I would say. So this is square minus 1, it will come out to be root 5 here. So should I write it down? V naught square to be 3GA, this is G into, this is 2, sine theta to be equal to root 5 by 6, and cos theta to be equal to 1 by root 6. So this 3, 2, 6 will cancel out, the G will cancel out, we are remain with root 5 into A. Okay, so we are getting the range from here to here to be equal to root 5 into A. So option D is actually the correct answer. So for question number 16, we found option A and D as the correct answer. Now let's proceed to question number 17.